We're on lesson 1 of chapter 6, which is circles. We're going to find the circumference of a circle, then we're going to find the area of a circle, and then a real-world application. Let's get on the same page for vocabulary. First, a circle is a set of points on a plane that are all a certain distance from a center point. Meaning, I have the center point here. If I go to the outside line of a circle, all these points on the line are the same distance from that center point, and they close off into a circle. So that's the definition of a circle. The radius then, which is blue here, it connects the center point here to any point on the circle. So that can be going in any direction to the outside of the circle. Therefore, it's half the distance across because it cuts out this other half. The entire distance across then is red here. That's the diameter. The diameter connects 2 points of the circle, this point and this point, for example, and then it has to pass through the center. It has to pass through the center, though. If it does not pass through the center, let's say we connected this point and that point, this would be a much shorter line because it's not passing through that center point. We're going to be finding the circumference of the circle. So what does that mean? The circumference is the distance, or the perimeter, you could say, around the circle. So if you start here and you measure all the way around this circle, that would be the circumference. So as we're going to find the circumference and areas of the circle, we're going to be using these formulas here. First of all, since radius is halfway across the circle and diameter is all the way across, the diameter is always going to be 2 times the radius. So whenever you're given the radius and you need to find the diameter, multiply that times 2. The circumference uses this figure called pi. It's usually signified in the shape of an N. Pi is usually written as 3.14, although with many decimals coming after that. It's usually just rounded to the 100th place, 3.14. And it's not just some random number. What early mathematicians notice is that when you cut this circle open, for example, and lay it out flat as a line, the length of the circle, or the circumference, is always 3.14 times larger than the diameter. No matter what circle you use, a big circle or small circle, that same number is true. It's 3.14 times bigger than the diameter. So that's why we use pi. So when we find circumference, we do the 3.14 times the diameter and get our circumference. We can also use pi to solve for the area, meaning how many squares we could fit in a circle. We can multiply pi times the radius squared. So the radius times the radius. So let's find the circumference. It says find the circumference of each circle both in terms of pi and to the nearest tenth. Use 3.14 for pi. So it gives us a circle with a diameter of 4.5 inches. If I remember my formula, the circumference is pi times diameter. So it gave us the diameter here. So now all we have to do is multiply 4.5 times pi. So we have 4.5 times pi, and then we would say inches. So that was pretty easy. We just had to insert the diameter and multiply that times pi. If we're actually going to solve it then, we would do 4.5 times 3.14, and that would give us 14.1 to the nearest tenth here, 14.1 inches. So we have to have two answers here in terms of pi, 4.5 pi, and then 14.1 inches. Now we have a circle with the radius of 4 centimeters. It doesn't give us the diameter this time. We have to turn this into a diameter. If you remember that a radius is half the diameter, so you'd multiply 2 times the radius to get the diameter. So therefore our diameter would be 8 centimeters. Remember that circumference is diameter times pi, so we'll say 8 times pi centimeters. Then if we actually find that out, we would do 8 times 3.14, which would be 25.1 to the nearest tenth. And there would be our answer. Now we need to graph the circle with a center of 2, -2, that passes through 0, -2, and then find the circumference in both pi and the nearest tenth. This might seem a little tricky at first, but if we remember that a circle is a set of points on a plane that are all a certain distance from the center, that should help us out here. The center is at 2, -2, and then it passes through 0, -2. So that means that everything that we have here is going to be 2 away from the center. So I know that this is also 2 away from the center. I know that this is 2 away from the center, and that this is 2 away from the center. Now that I have my 4 points, I can make my circle. It's not going to be perfect at all, so bear with me here. It's going to somewhat look like a circle. Yep, and that's where I made the mistake. So this is my makeshift circle. If I'm looking for the diameter, I see that all the way across through the center point is 4 units. So if we're going to write that out in terms of pi, 4 times pi would just be 4 pi units. And if we're actually going to solve that, then it would be 4 times 3.14, which would be 12.6 to the nearest tenth, so 12.6 units. Now we need to find the area of each circle, both in terms of pi and to the nearest tenth. Use 3.14 for pi. If we remember our formula here, area is radius squared times pi. So if it gives us the radius here, we can square that and multiply that times pi. Well, I know that 5 times 5, 5 squared is 25, so I'd do 25 times pi. And that would be centimeters. So if we do 25 times 3.14, that would be 78.5, and we don't need to round there, centimeters. Remember, since this is 2 dimensions, area is how much stuff fits in it. We're going to need to square the centimeters as well. So let's do that to this and this. Area needs to have squared units. So now it gives us the diameter of 5.6. Remember, we need to find the radius. So the radius is half of the diameter, right? So we could divide the diameter in half and then square it. So we do 5.6 divided by 2 would be 2.8 radius. So we do 2.8 squared times 2.8, and that would be 7.84. So the area would be 7.84 times pi inches squared. If we're going to find that out, 7.84 times 3.14, it would be 24.6. So it would be 24.6 inches squared. Here we have to graph that same circle and now find the area of that circle. I'm just going to copy that circle in here to save us time. If we remember our formula, radius squared times pi, I know that the radius here is 2, so I could do 2 times 2, which is 2 squared. That equals 4. So I could do 4 times pi. So 4 pi units squared. 4 times pi would be 12.6. So we're going to say 12.6 units squared. And those would be our answers. If you notice, these answers match the circumference answers, except for the squared part. That's because 2 squared equals 4. That's not going to happen for all circles. Usually the area is going to be much larger than the circumference. Let's do this real-world application. The radius of a circular swing ride is 29 feet. If a person is on the ride for 18 complete revolutions, how far does the person travel? Use 22 divided by 7 for pi. If I do 22 divided by 7, it's the 3.142857. It's much more precise, pi. So we need to go around and around. That's not the area, that's the circumference. So first we need to find the circumference, which would be 1 revolution, and then we need to multiply that times 18. So the radius is 29. I know that diameter is 2 times the radius. So we do 29 times 2, which is 58. So 58 times pi would be the circumference. So 58 times 22 divided by 7, which is the 22 over 7. That'd be 182.285. Now let's multiply that times 18 because we're going around 18 times. Now we have 3,281 feet, and we'll round to the nearest tenth again, so 0.1. So 3281.1 feet. So that's how many feet you're going to travel if you do 18 complete revolutions. It seems like a lot, but this is a very big circular ride.